If you've spent any time around crypto lately, you've heard the names. Arbitrum, Base, Optimism. They process huge volumes of transactions. They're where a lot of crypto activity actually happens, and they're often discussed as if they're competitors to Ethereum. Faster, cheaper chains that won where Ethereum lost. That framing is backwards. These networks didn't beat Ethereum. They are Ethereum's scaling strategy, the one Ethereum's own developers deliberately chose. But the way that strategy has actually played out looks very different from the way it was originally drawn up. Let's walk through what Layer 2s are, why they exist, and what actually happened. Start with the problem. We covered this in our Ethereum explainer. Ethereum is a world computer. Anyone can deploy a program to it, and the whole network executes that program faithfully. The catch is that the whole network executes it is expensive. Every node has to run every transaction. That makes Ethereum secure and decentralized, but it also makes it slow and, at times, brutally expensive. During peak congestion in 2024, a single token swap on Ethereum could cost $50 or more in fees. A world computer that costs $50 per click is not a world computer most people can use. So Ethereum needed to scale. If you saw our video on the Lightning Network, this is the same core problem Bitcoin faced. A base layer that's secure but can't handle volume. Bitcoin's answer was Lightning, a payment network built on top. Ethereum's answer had to be different, because Ethereum isn't just moving payments. It's running programs. The path Ethereum's developers chose is called the rollup-centric roadmap. Instead of making the main chain itself process more transactions, push the activity to a second layer and let the main chain do what it does best. Provide security and final settlement. That second layer is what a Layer 2 is. Here's how a rollup works. A Layer 2 takes hundreds or thousands of transactions, executes them on its own faster network, bundles them together, and posts them back to Ethereum's main chain. And here's the part that's easy to get wrong. A rollup doesn't just post a summary or a fingerprint of the final result. It posts the actual transaction data, compressed and batched. That's literally what the word rollup means. The transactions get rolled up into a batch and posted to Ethereum. Why does that matter? Because if only a summary went to Ethereum, you'd have to trust the Layer 2 operator that the summary was honest. By posting the underlying data, anyone can independently reconstruct what the Layer 2's state should be and verify it themselves. The data living on Ethereum is what makes the security real instead of trust-based. That's also why a Layer 2 is not a separate blockchain competing with Ethereum for security. It borrows Ethereum's security. If you can trust Ethereum's main chain, you can trust the record a rollup posts to it. The Layer 2 gives you speed and low fees. Ethereum gives the Layer 2 its trustworthiness. They are not competitors. They are layers of the same system, which is exactly what the name says. There are two main types of rollups, and the difference is in how they prove their transactions are valid. Optimistic rollups, which include Arbitrum, Base, and Optimism, do what the name suggests. They assume the transactions are valid by default. They post the data to Ethereum and allow a window of time, typically 7 days, during which anyone can challenge a transaction they believe is fraudulent and prove it. If no one successfully challenges, the transactions are considered final. ZK Rollups, which include networks like ZK Sync, Starknet, and Linea, post their transaction data the same way. But instead of assuming validity and waiting for challenges, every batch comes with a cryptographic proof, a piece of math that verifies the transactions were processed correctly. Ethereum checks the proof. If the math holds, the batch is final. No waiting period. The trade-off is roughly this. Optimistic rollups have been around longer and are easier to build on, which is why they have the most activity and the deepest ecosystems today. ZK Rollups offer faster finality and stronger mathematical guarantees. But the technology is harder to build, and some of them still rely on centralized components they're working to decentralize. Now, the thing that changed everything. In March 2024, Ethereum shipped an upgrade called Dencun. The key piece of it created something called blobs, a separate, cheaper data lane specifically for rollups to post their data. Before Dencun, rollups had to compete with regular Ethereum transactions for the same block space. After Dencun, they had their own lane. The effect was dramatic. Layer 2 transaction fees dropped by roughly 90%. Transactions that might have cost $1 or more on a Layer 2 now cost a few cents, sometimes a fraction of a cent. The world computer got cheap. But here's the twist, and it's the part most explanations leave out. The original vision for Layer 2s was pluralistic. 1,000 rollups, each serving different communities and use cases, all settling back to Ethereum. A decentralized ecosystem of scaling solutions. That is not what happened. What happened is brutal consolidation. As of 2026, there are more than 70 active rollups. But just 2 of them, Arbitrum and Base, hold roughly 3/4 of all the money on Layer 2s. 3 networks process around 90% of all Layer 2 transactions. Most of the other 70+ are what the industry now openly calls zombie chains, technically alive, but with evaporating activity and fleeing developers. One prominent Layer 2, Blast, saw its deposits collapse by 97% after a disappointing token launch. And here's the irony. Dencun, the upgrade that made Layer 2s cheap, is part of why they consolidated. When launching a rollup became trivial and fees dropped to near zero everywhere, fees stopped being a thing you could compete on. What was left to compete on was distribution. Base won enormous market share not because its technology is dramatically better, but because it's operated by Coinbase and plugs directly into Coinbase's 100 million+ users. Arbitrum won by focusing on one thing, becoming the deepest pool of DeFi liquidity, and compounding that lead. Optimism is the most interesting case here. As its own chain, OP Mainnet, it trails both Arbitrum and Base by a wide margin. But Optimism's underlying technology, called the OP stack, is the framework other chains are built on, including Base. So Optimism arguably built the most widely used Layer 2 technology in all of crypto. It just isn't winning on the chain that carries its name. That gap between building the best technology and capturing the most users is the whole story of Layer 2 consolidation. So back to where we started. Did Ethereum's Layer 2 strategy work? Mechanically, yes. Ethereum needed to scale, and it did. Fees collapsed. The world computer became usable. The activity moved to Layer 2s exactly as the roadmap intended, and all of it still settles back to Ethereum. But the strategy didn't produce the decentralized 1,000 rollup ecosystem the early vision imagined. It produced a handful of dominant winners, chosen largely by distribution muscle. Layer 2s didn't abandon Ethereum, and they didn't lose to it. They extended it. They just extended it into a shape the original blueprint didn't quite predict. That's Ethereum Layer 2s. We cover crypto on the days that actually matter, with explainers when it helps. Hit subscribe so you don't miss it. We'll see you next time.